Hi everyone. Today we are going to discuss about colloids. In this session, the topics to be covered are introduction of colloids, and types of colloids. First, let us see introduction of colloids. The term colloid implies glue-like substances. Next one is colloidal systems. Colloidal systems is a dispersion where dispersed particles, here the dispersed particles nothing but internal phase is distributed uniformly in a dispersion medium. Here the dispersion medium is nothing but an external phase or continuous phase. Okay, colloidal systems is a dispersion where dispersed particles we are is a internal phase is distributed uniformly in a dispersion medium, nothing but external phase. What is dispersion medium? Sorry, what is dispersion systems? Dispersion systems consisting of a particulate matter nothing but a dispersed phase. Particulate matter nothing but a dispersed phase is distributed throughout a continuous or dispersion medium. This particulate matter can be measured in various size ranges from atoms or molecules. These size ranges can be measured in millimeters. These dispersed systems can be classified as dispersed systems are classified into three types. Those are molecular dispersions, colloidal dispersions, or coarse dispersions. Okay, dispersed systems is nothing but a dispersed particles. Dispersed phase is distributed in a continuous phase. These dispersed systems can be measured in various size ranges. Those size ranges are atoms or molecules, and those can be classified. These dispersed systems are classified into three types, that is molecular dispersions, colloidal dispersions, coarse dispersions. These molecular dispersions, they are various size ranges. Those size ranges, molecular dispersions having the size range of less than 1 nanometer. And those examples are ions and glucose. These molecular dispersions having high permeability and having high diffusion. And next one is colloidal dispersions. Colloidal dispersions having size range from 1 nanometer to 0.5 micrometers, and they're having examples like cheese, butter, jelly, paint, natural, and synthetic polymers. Etc. These colloidal dispersions, they cannot filter through semi-permeable membrane or filter paper. Hence, their diffusion is low. Whereas in molecular dispersions, there is a high permeability and high diffusion. Coming to colloidal dispersions, the size range is 1 nanometer to 0.5 micrometers. Examples are cheese, butter, jelly, paint, natural and synthetic polymers, and they cannot filter through filter paper or semi-permeable membrane, and the diffusion is low. And next one is coarse dispersions. Coarse dispersions having the size range of greater than 0.5 micrometers. Examples are grains of sand, emulsions, and suspensions. Here, these coarse dispersions are filtered through filter paper, because of high molecular weight. Because of high molecular weight, they can be filtered through a filter paper. Hence, there is no diffusion, no diffusibility for these coarse dispersions. Hence, they cannot permeate through semi-permeable membrane. They cannot permeate through semi-permeable membrane. And next, how these colloidal dispersions, molecular colloidal dispersions, separation techniques. These colloidal particles can be separated from molecular particles. Colloidal particles. We are separating separation techniques. We are using first technique is dialysis. Dialysis using a semi-permeable membrane, that is a cellophane or colloidal. Cellophane or a colloidal. For this, we are taking a tumbler having two compartments, A compartment and B compartment. Both compartments are separated by a semi-permeable membrane. This condition is at initial state, and this one is at equilibrium. Here we are placing in an A compartment, we are placing both mixture of colloidal particles, that is colloidal particles along with molecular particles. Initial state at this system when attains equilibrium, the colloidal particles are separated from molecular particles. So this is the dialysis. And next one is next separation technique is ultrafiltration. Ultrafiltration. In this ultrafiltration, the filtration is carried under negative pressure. Under negative pressure, hence suction through a dialysis membrane. By this suction, the molecular particles, colloidal particles are separated from molecular particles. Whereas this dialysis and ultrafiltration, both the separation techniques are used to remove charged impurities. Are used to remove charged impurities such as ionic contaminants, ionic contaminants. And this process is hastened by the use of electric potential. This both ultrafiltration as well as dialysis. Both the process can be carried with the help of a electric potential. Then this process is called as electrodialysis. Once this electric potential is applied across the semi-permeable membrane, then the separation can be occurred. The colloidal particles are separated from molecular particles. With the help of electric potential, we are calling that process is called as electrodialysis. This is a separation techniques. Let us coming to the definition of the colloids. Colloidal systems are defined as a polyphasic systems. Colloidal systems are the polyphasic systems where at least one dimension of dispersed phase measures between at least one dimension of dispersed phase measures between 10 to 100 angstroms to a few micrometers. Is a polyphasic system whereas at least one dimension of the dispersed phase measures between 10 to 100 angstroms to a few micrometers. And this is about the introduction of colloids. Next, types of colloids. Okay, there are two types of colloids. Lyophilic colloids. First one is lyophilic colloids and second one is lyophobic colloids. Lyophilic colloids, nothing but solvent loving. Lyophobic means solvent hating. Okay, first discuss about lyophilic colloids. Solvent loving systems. Lyophilic colloids In this, dispersed particles have great affinity. Dispersed particles have greater affinity to the dispersion medium. Dispersed particles have greater affinity towards the dispersion medium is in lyophilic colloids, whereas dispersion medium is surrounded by a sheath around the colloidal particles. There is a protective sheath around the colloidal particles and solvents. This makes this sheath, because of this sheath surrounded the colloidal particles, because of this, lyophilic colloidal systems are thermodynamically stable. These are thermodynamically stable systems. Hence, in this lyophilic colloids, the preparation of lyophilic colloids is easy and they can be easily prepared, and this dispersion is reversible, whereas the colloidal particles are reconstituted. Colloidal particles are reconstituted after purification. After purification step, they again reconstituted. That's why those are reversible systems. Examples: acacia, gelatin, starch dispersions in water. These are solvent loving systems. Okay, and the type of colloids is lyophobic. Lyophobic colloids or solvent hating system. In this, dispersed particles have very little attractions. Dispersed particles having very little attractions. Towards the dispersion medium. Hence, these systems are somewhat stable because of charged particles. These systems are also stable because of charged particles, whereas the solvent sheath around the colloidal particles is absent. The sheath around the particles, around the colloidal particles is absent. Because of this, because of absence of the sheath around the colloidal particles, these systems are thermodynamically unstable. Examples: gold, silver, silver iodide in water. This is the types of colloids. The colloids there are two types of colloids: lyophilic and lyophobic colloids. In this lyophilic colloids, there are solvent loving systems. These are solvent hating systems. Whereas dispersed particles have great affinity towards the medium is a lyophilic colloids. Here there is a very little attractions, and in this lyophilic colloids there is a sheath around the colloidal particles. Because of this sheath, these systems are thermodynamically stable systems, and this preparation is very easy, and it is a reversible systems, because it can be, the colloidal systems can be reconstituted after purification step. Examples are acacia, gelatin, starch dispersions in water. And lyophobic colloids. Lyophobic colloids, phobic is nothing but a hating, solvent hating systems. They have very little attractions towards the dispersion medium, and these systems are stable because of the charged particles. But there is an absence of sheath around the colloidal particles. Because of that, these systems are thermodynamically unstable systems. Examples: gold, silver iodide in water. Okay. Thank you, everyone.